Okay, so I'm going to try and offer some videos to you guys periodically throughout the year, throughout each unit, to hopefully keep you on track in geometry. This is page 4 of your textbook, and the direction we're going here, now that we're finally beginning geometry and stepping away from probability, we're going to begin with just some naming conventions. So if you're the sort of person that needs notes, I strongly encourage you to go to page 4, use these definitions, and then recreate your own examples in a way similar to what I'm about to do. So we have naming conventions in geometry. This would be called point M, and I'm going to use that point to expand out and show some other things from that table, basic things. If I put another point here, G, and connect them with a line, I now have line segment MG, and I would just put 1 bar on it. That's a way of saying line segment MG. And let's evolve that. Let's draw an arrow off this direction. Then I would come over here and I would put an arrow on top of here, and this now becomes ray MG in accordance with that definition in the table on page 4. If I extend the line here and add an arrow, I would add an arrow up here, and now this is line MG. So just keeping those things separate is going to be real helpful. And when it comes to sort of developing a common vocabulary for the geometry class. The last thing from that table is the plane, and instead of adding a point to the page, I want you to imagine that the tip of my pen is the third point. You can call it whatever you want, but notice how that third point is required to make a plane. If you want a piece of paper to function as the plane, well, then you need it to be able to move around in 3-dimensional space. And it's not that a line or a ray or a line segment can't move in 3-dimensional space, but you can only go in 2 up or down here. You need a third point somewhere to create a plane. And maybe the most obvious example would be just to add 1 more point to the page. We'll call that point P. And now, your instinct might be to say, okay, well, all I have is a triangle, but the point is you need that third point in order to create new dimension, a 3-dimensional plane. Before you were constricted to only going up and down, but now you can go up, down, left, and right, and we can create, by any point from this line that passes through this point. What we end up doing is creating a plane. So I'm not trying to overcomplicate things here. The idea is you need 3 points to make a plane in order to travel in multiple directions instead of just up and down or left and right or back and forth to do the combination of those things. So in short, 3 points make a plane, and all I'm really doing here is just going through the basics of this table on page 4. Another place where naming conventions are really important is with angles. So let's say we had these lines intersecting in a plane, and we'll label all the important points here. Maybe this one is a ray, Maybe this one is just a segment. Maybe this one is a line. And now let's name some things here. Let's make it easy. This is point A, point B, point C, point D, point E, and let's add another one down here, point F. So we want to name things. We want to name angles, and it's always going to take, well, not always, it's often going to take 3 points in order to name an angle. So for example, angle BCE would be angle, this one right here. And take note of how the C, the vertex, is between the B and the E. That very same angle could be named ACE because it's from point A to point C to point E. We're talking about the same angle. So you could name that angle 2 different things. Let's see here. This angle on the outside, this is an obtuse angle because it has an angle measure greater than 90 degrees. We would call this angle one of 2 things. Either FCB or angle FCA, or you could even reverse it and you could call that angle BCF or angle ACF. And the whole point here is not to stress out and try and figure out what are all the names of this angle. It's just so we can have a common vocabulary. When I say angle FCB is, I don't know, 140 degrees, you need to know exactly what I'm talking about. If I were to call it ACF or BCF or FCA instead of FCB, we just need to have this common vocabulary to know what we're talking about. So if I were to then say, identify for me angle DCE, it's pretty easy for you to look at this diagram and go, okay, DCE is this angle right here. It's an acute angle, and maybe it's 40 degrees. I don't know. I'm just making things up. So this would be angle DCE. And then there's a right angle in here that has several different names, BCD or ACD. And then there's this large obtuse angle here at the bottom, FCD or DCF. So I think the crucial takeaway from this is that you're pretty much always going to need 3 letters in order to indicate what your angle is, and then the vertex is always going to go in the middle. And because of the way this diagram is set up, that vertex is always going to be C. Now, having said that, allow me to break the rule that I just stated. Let's say we had this right here, and no, this, no, I'm not going to break the rule. Let's say we had a simpler diagram, A, B, C, D, and then suppose you had an even simpler diagram right here. This is the point I'm trying to illustrate. This is C, B, D. In this case, this simpler case right here, just these 2 intersecting line segments, or maybe just for fun, we'll make this a ray and this just a line segment. So here we have ray BD and line segment BC intersecting at point B. So, taking advantage of the common vocabulary I'm trying to create. This one you could get away with calling this angle B because there's no other angles in that diagram. Angle B is obviously the same as angle CBD. Now compare that to this one up here. You can't get away with calling this angle B, because if I said angle B, you would rightly be confused between whether or not I was talking about CBD or ABC. So in this case, you absolutely need to distinguish between angle ABC and angle CBD. Whereas in this case, you can kind of get away with just saying angle B. However, I don't think that's worth getting hung up on. Just be sure that you're identifying things clearly in an unconfusing way. And this method right here, 3 letters, is always going to be more than enough. So maybe just stick with that one. And let's just explore this vocabulary that I'm trying to create a little more. Let's say we put some arrows on the end there. We could call this diagram here, we could call this line segment, not line segment, we would call this line AD, but we could also call it line AB, because A and B are 2 points on the line. You only need 2 points for the line. We could call it line BD, and but this one right here, BC, because there are no arrows on the end, would just be line segment, and there's only 2 points on the line, so we don't have anything else we could use for the name. So that's simple naming conventions for angles and for lines. We're going to be using them a lot in class, but I'm making this video for you so that maybe you can, when you're on your own time, you can study with it. One more thing that's probably worth doing is talking about circles and their various features and their names. You know some of these already. So here's a circle, and let's just make that point its center. There are several different types of lines we can do. We'll make all of these line segments intersecting the circle. If this is the center of the circle C, and this is A, B, D, we have several different types of line segments here. C, D, and AC are radii. Line segment AD is the diameter, and then line segment AB is what's known as a chord, and that's probably the only new piece of vocabulary. A chord is any line segment that connects any 2 points on either side of the circle. So if this was E and F, we would have chord EF. And it's worth noting that the diameter AD is also a chord. It's just a special type of chord that cuts the circle in half. Okay. And let's think about, before I end this video, what could we name this angle right here? Well, we could get away with calling it angle A, because there's no other angles there. But we're probably better off calling it angle BAC or angle BAD, and not getting into arguments over who's right about calling it BAC or BAD, because both of those are right. We're just agreeing on names, so when we talk about things, we talk about angles, we talk about circle parts, we talk about measures and lengths, we know what we're talking about. Okay. So I hope you find this video helpful. It's basically an introduction to the first 2 chapters of the textbook and the real geometry that we're going to be doing from here on out to the end of the year. The practice associated with this little lesson is pages 11 and 12, and I'd say all of the problems, because why not do all the problems? They're good practice.